Sir Emily, it's Cosmic Ray, the quantum mechanic. We're here today again. We're going to do vitamin C with our Schroeder Diamonds. The Schroeder Diamond is the most important carbon in any compound. What we're going to do is show both states of this. Okay, so the first one, this is going to look really cool, is what we ended up with here was something that resembled a car. So let's see if I can do that again. We had the carbon to carbon, and then what we had here, I'm just going to go up to there. So remember, try and always get the sides whenever it's a carbon to carbon bond, okay? And since this is going to be the bottom of the wheel, let me just write it here. Vitamin C. What we end up with here, alcohol group. We should draw this really big if we're drawing it true to scale, right? Whoops. Famous last words. Whoops. And remember what you can do if you're in coloring, remember to make things look more highlighted. You would trace them. So if you have like a really dark green one or dark colored one, see if you trace this with black, it would really show up better. So we're giving these things wheels. What's on the inside of an alcohol? Proton. So there's red. Red. Coming up the side here, we always go corner to corner for the diamonds. So here's side group to carbon. We're going to go up a single to the oxygen off the tippy top there. So here's an O. Go off the top of this. So far, what we end up with is a double bond across here, too. So see how cool that is? We already got like a little car out of it. And then off the ends, we've got 3 carbons right in a row. So check this out. We're going to draw them right next to each other with no line in between them. Remember how we drew the fats? So here's the 3 carbons on the tail. Picture like some old hot rod. But remember they had the little raccoon tail hanging off the end there? You get 3 carbons hanging off. One of these has an alcohol group on it. So we can put that right on the tip. And this other one has an alcohol on the bottom. So see, this is like coloring, but you're really making a molecule. This is what vitamin C looks like. Kid you not. Right in there, alcohols. See, those are alcohols. But this gets here, I drew too close, I messed it up. This gets a carbonyl group. Double bonded, oh, see, I already messed it up. 2 bonds worth anyway. I'll make it 3D or something, I guess. So we already messed that up. That's it. That's all there is to vitamin C. So what can we do? We can draw a little smiley face, got a lone pair of electrons. So there's a lone pair of electrons. And smile. Kind of negative charge. See up there too? So green's got to have electron density to it. So here I think our white balance is off a little because it's not showing very good. That's vitamin C. Now see the double bond in here? Those are alcohols down there. We're going to draw this again. It acts as an antioxidant. Watch here. This is vitamin C reduced. This is chemistry here, okay? Oh, that's what vitamin C looks like. Well, what does vitamin C do? That double bond across the front there takes the electrons. Actually, what is happening? I got to make sure I get this straight because the proton's on the bottom there. Well, let's draw it first. We start with our 2 main carbons across. Carbon, carbon. See, we just draw them as triangles. All we got to do. We don't even have to think about it yet. There's 4 carbons in a row. Now we focus on the oxygens. So up here's the oxygen for the ring. Up there's the oxygen for the ring. We're talking about alcohol groups here, but what actually happens, we should have thought about this before I drew that in there. But here's a double bonded O. Here's a double bonded O. So we color those in all the way, right? Remember? Let's even color it into the carbon. Maybe that's a new way of doing this here. Because see, there is a pi bond up there. There's going to be one that's going to be like a straight line. But then it's going to fill in on like both sides of that. So what happened was a double bond went to this. And what do we have out here? We just had 3 carbons, right? So just draw 3 diamonds. Don't even need to think about it because diamonds are going to be on the sides. Now it's a matter of just filling in the 4. These carbons are taken care of with those double bonds on there. On the end up here, on vitamin C, this has a double bonded oxygen too. So watch what this does. This goes like this. Totally green. So we'll make oxygen really big, because oxygen is big. Draw it as a circle. Right, then you have the circle in there. So think of this now. Here, color that in all the way green too, because this is the beauty of being able to use this. This shows what it really looks like. These over here still are alcohols off the end. So you got an OH here, and an OH on the tail there. So the OHs, if you recall, we just draw the little proton in the middle. So think of it, it's still able to give up a proton on there. That's kind of confusing because proton hydrogen stuff on there. But look how many oxygens there are here. You got 2 alcohol groups. You got 1, 2, 3 carbonyls, they're called. There's probably another name when they're next to each other like that. And is that right? You actually have 1, 2, 3 carbons with double bonds on them all next to each other. Wow. That is something. Vitamin C is a cool vitamin, folks. So for users that want to do the bookkeeping, go through now. If you got double bonds on these guys, kind of help to color it in. I mean, those carbons are all saturated. So those 3, let's color them in now, just to get them out of the way. So that's what you can do is, as soon as you're done with it, color it in. If it's got all the ones that it needs, color it in, and then you're done with it. See the beauty of that, kids, now? So when we come along to here, okay, we can encircle it in black because that means we're done. So see, now it really shows up better, huh? Sigma bonds. Come to this carbon. What has this got? Bond to an oxygen, bond to a carbon, bond to another carbon. Needs a dot. This here, carbon. Oh, so we can color it in now. See, we're done with that. We focused. It's got all 4 bonds. We're done. Come to this carbon. Looks like it needs one up there, right? Draw hydrogen on there. What do we get to do? Color it in. We're done. Get her done. This is, what's his name's chemistry? Redneck chemistry. Want to go to this carbon here. OH on the end. 2 hydrogen dots on the end. So see, you'll become familiar with these later on. These are all carbon compounds with the hydrogens on the end. CHs they call them. Well, you'll just be thinking of them as carbons with dots. So this is vitamin C reduced, which means it's got a double bond down there. Because it used to have the double bond on the carbon. So see the difference? This is where the cartoon really comes in handy, I think. So here's vitamin C. Along comes hydrogens with electrons. Vitamin C reduced. All happens in that double bond right there. So you can compare it. So you can draw these. It'll look different every time it looks like